Okay, so we are going to put everything together today, and then we're going to try to look at all three different types of quadratic, and when do we use what, and can we find information if I know, for example, the factored form, or how can I find information if I know the standard form, and so on and so forth. So we're going to look at the whole picture. So remember that with quadratic, we have the three different forms, right? We have the factored form, we have the standard form, and the vertex form. So what can I find from the factored form? What can I find from the factored form? The x-intercept. That's right. So from the fact form, I can find intercept. So let's say this here and here. Okay, this is just, I'm just sketching something here. Now I know my x-intercept from the factored form. How can I find, or where would the vertex be located if I know the two zeros? Can I find where my vertex is? What do we know about quadratic? What do we know about parabola? What's special about the parabola shape? It has a vertex. What else? It has an axis of symmetry. And then everything is symmetrical, right? So that means if I have a parabola, I don't want you to write anything, I just want you to look at me right now. So if I have a parabola, according to the vertex, everything else is symmetrical. So from here to here is equal to from here to here is equal to from here to here, right? So I have a symmetry, okay? Don't write this. Now, because I know my two zeros, where do you think the vertex is going to be with respect to the two zeros? Yeah.
She said y-intercept.
Well, in this case it is, but it doesn't always have to be in the y-intercept. What if my two zeros are right here? Where would my vertex be?
The middle of it.
In the middle. That's right. Because technically speaking, right, it's axis of symmetry, right? And the axis of symmetry is what cuts the graph in half, right? And my vertex lies somewhere on that axis of symmetry, and then we have to find where that somewhere is. Okay? So if I know my two zeros, I can find my axis of symmetry. Correct? So from the factored form, I can find my two zeros. Once I find my two zeros, I can find the middle. And then we'll see what happens. How can I find my optimal value? Okay? So now, if I want to find the vertex when it's in factored form, first you must find the zeros. Or the x-intercepts. So if I'm looking at this, what would I call the x-intercepts? What are they called? What would they be? R and S. After I find the zeros, I can find the axis of symmetry by, how can you find the middle? What do you do to find the middle?
Add them together and divide 2.
Add them and divide by 2. That's right. So then you're going to find the axis of symmetry. By adding the two zero. And dividing by 2. So I do R, so to find the axis of symmetry, I do R plus S, and I divide my answer by 2. Now I know the axis of symmetry, and I know that the optimal value is the y value of the vertex, right? So if you guys remember, my vertex is hk or xy, right? Where h is the axis of symmetry, and then y is the optimal value. Do you guys remember that? You remember that? So the h value is the axis of symmetry, and the k is the optimal value, right? So if I know the x, and I plug in the x in for x, then I can solve for y. Okay? It will make more sense when we look at examples. All right? So the third step is you're going to plug the axis of symmetry in for x. And solve for the optimal value. And that would give you your vertex.
Is that a K?
Mhm. So here's an example. What form is this in? Fact. So it's asking you to solve for your zeros, or the x-intercept. How do you know this is factored form? It's in brackets, they're multiplied, right? Okay. So what would be your zeros?
X equals 2
Yeah?
and X equals 8.
So x equals 2, x equals 8, because you're going to set each bracket equal to 0, right? And then you're going to bring solve for x. So I have x equals 2, and I'm going to set the other bracket equal to 0, and that's going to give me x equals 8. So my two zeros are 2 and 8. Anyone doesn't know how to do this step? Are we okay? Now, to find the axis of symmetry, we said I have to add the two zeros and divide by 2, because my axis of symmetry is going to be in the middle between the two zeros, right? So, axis of symmetry, you're going to add the two zeros, and then you're going to divide by 2. 2 plus 8 divided by 2. So that's going to be 10 over 2, which is 5. Found the answer. I found the answer, so I didn't need. Oops. Okay, so far I know my two zeros, the 2 and the 8, and then I figured out that the axis of symmetry is at 5, 2, 3, 4, 5. So that's where my axis of symmetry. Look at this. Does it look it's in the middle between the 2 and 8? Good. So this is where my axis of symmetry is. Now the question is, where is my optimal value? So is my vertex here? Is my vertex here? Is my vertex here? Is my vertex here? Where is my vertex? Where is my optimal value? So I found part of the vertex. Now I need to find the other part of it. Okay? Now, how do you find the optimal value? To find the optimal value, you're going to take the axis of symmetry and then you're going to plug it in for x. Remember that the axis of symmetry is the x value. Okay? So, you're going to take the axis of symmetry and then you're going to plug it in for x. So I have y equal -3, 5 minus 2, 5 minus 8. So that's going to give me -3 times 3 times -3. So that's going to be 27. So my optimal value is at 27. So this is where my vertex is. Does it make sense that if I'm graphing this, it's going to look like this?
Yeah.
Does it make sense that it's open downward? Yes, because my A value is, what's my A value?
Positive.
What's my A value? -3, and negative opens which way?
Downwards.
Negative A, right? Negative opens downward. All right. So, do we understand the steps? Find the zeros, add them and divide by 2 to find your axis of symmetry, plug in the axis of symmetry to find the optimal value. Are we okay with that? Now, so what's my vertex point?
5, 27.
So the vertex is 5, 27. Now, I want to write it in vertex form. What's my vertex form? What's the general form for vertex form?
Y equals A bracket H minus A,
X.
X minus A squared
Yeah,
plus K.
good. Do I have enough information? Yeah. Do I know, what do I know? Do I know what my A value is? What is it? -3. Remember that the A value is the same for all three forms. Okay? So that A value is going to be the same for all three forms.
Yeah. If there's nothing there, you just like,
1.
you have to write that though.
What's my H value? So it's going to be x minus 5 squared plus 27. Is this my vertex form? So this is not how we actually, so what we did here, we went from factor to vertex, right? But there is a method that we can go from standard to vertex, but we don't learn it here, okay? So this is basically the backdoor way to find your vertex from factored, okay? This is a cheating way. Are we okay with that? So far? Now, it's asking me to convert to standard form. Does it matter if I convert from vertex form or from factored form?
Factor form.
Does it matter though? It doesn't matter, right? I can use either forms to convert. I always go back to my original just in case I made a mistake so I don't make the same mistake over and over and over again. Okay? So I usually always like to go back to my original if I can. Okay? So in this case, I'm going to use my original to convert. So what do I have to do to convert to standard form? What's the process? Expand. Okay, which is foiling, right? So I'm going to foil x times x, x times -8, -2 times x, -2 times -8, plus 16. And now I'm going to distribute the negative 3 in. So I have negative 3x squared plus 24x minus, or plus, sorry, 6x minus 48. And let's collect the like terms. Now it's in standard form. What is your y-intercept? Huh? Negative 48. Look at this. A value is negative 3. Right? A value is negative 3. A value is negative 3. Okay? All three forms have the same A value. That's all what we learned in quadratic, guys. Vertex form, factored form, standard form, expanding, finding the zeros, finding the vertex. This is everything we learned so far. Finding the y-intercept. Do you see that? Putting the puzzle together. So that if I have the factored form, this is what I need to do. Now to find the vertex from quadratic in standard form, there is a way, but then we don't learn it here as I said. But we know how to factor, don't we? We know how to factor. So what I can do is, from standard, I can factor, and then I can do what I did earlier. Okay, so that's an extra step. So if it's standard form to vertex form, you're going to factor and then follow the steps above. Let's look at an example where we have to follow this. Okay, so we're going to go to the next page. What form is this in? Standard. What can I find from the standard form?
Y is the same.
Which is what?
Negative 18.
Perfect. So the y-intercept is negative 18. To find the zeros, what do I need to do? Factor it. It's a trinomial, 1, 2, 3 terms. So what process do I follow? Sum and product. So my sum and product is going to be, I'm looking for two numbers that multiply to, add to, what multiplies to negative 18 and add to negative 3? 6 and 3. And then because both of them are negative, that means my large one is going to be the negative 1. So it's going to be negative 6 and 3. Okay? Now because I've already factored, so I just have to put them in x minus 6, x plus 3. Are we okay with this part? So what are my zeros?
6 and 3.
So the zeros are x equals 6 and x, I shouldn't be writing here. Negative 3, right? So factor it, find the zeros. plus minus 3. Okay? Because this is a negative 3. Because if I do x plus 3 equals 0, bring the 3 over, it becomes a negative 3.
Oh, I thought I was going to make it.
No. So, to find the axis of symmetry, I'm going to have to add the two zeros. So 6 plus minus 3 and divide it by 2.
What did it just be 6 minus 3?
Yeah. And 6 minus 3 is 3 over 2, which is 1.5. So my axis of symmetry is 1.5. Then you can plug in the axis of symmetry in for x to solve for the optimal value. Okay? So to find the optimal value, I'm plugging in 1.5 in for x. How many of you understand the steps? Understand. To find the optimal value, I need to plug in the axis of symmetry. What do you get for this?
Is that negative 4.5?
Yeah. Should be negative 20.25. Is that right? Yeah? Is that what you got? So what's my vertex?
1.9, that would be 24.
And then to write it in vertex form, you just have to write your original format.
Is axis of symmetry x?
Axis of symmetry, yes, it's x. And this is y. Okay?
Possible value
Yeah. What's my a value here?
1.
So I don't have to write it. What's my h?
1.
And then my k is minus 20.25. And that is my vertex form. Right? You're multiplying negative 4.5 times 4. Are we okay with this? And the last one, I'm going to go back to the previous page. If it's in vertex form, how can you find the vertex? H and K. It's the easiest form, right? Because it's already in vertex form. So the vertex is just HK. So I don't even have to do any work. And remember, H is the opposite sign, right? So if you see it as a negative in the bracket, that means it's a positive as an H.
So it would be like, for this, it would be like 2 and 5.
Yep. So, vertex form is y equal negative 3x minus 2 squared plus 5. That means my vertex is 2, 5. Is the vertex a max or a min? And how do you know that? A value is negative, so it's going to open down. So that means I have a max. Perfect.
Isn't it a max team if the number is bigger than one, or is that that's different from that stretch?
How can I convert this to standard form? Expanding. And how would I expand this? What do I have to write? So how do I expand this? What does it mean by x minus 2 squared?
You have to write it twice.
I have to write it twice. X minus 2 times x minus 2. Okay, this is what we did in the quiz. And then what did we have to do after that? Foil the x minus 2 times x minus 2. So that gives me x squared minus 2x minus 2x plus 4. Anyone have any questions about this? Now,
Don't you multiply the -3?
yeah, distribute the -3 in. So that's going to be negative 3x squared plus 6x plus 6x minus 12. So remember that you're multiplying the -3 into each term inside the bracket. Then collect like terms. It's in standard form. Now, what can you find from the standard form? Y-intercept, which is negative. Any questions about these three different forms and how to convert from one to the other? Let's look at this question. So the flight of a baseball is modeled by y equal negative 4.9 x squared plus 9.8 x plus 14.7, where x is the time in seconds and y is the height in meter above ground. What is the height of the ball 0.5 seconds after it was hit?
X equal 0.5.
Yeah. Guys, read, right? So we're going to have to read. It says x is the time. Y is the height. So the question is asking you, what is the height? So it's asking you to find the height. So it's asking you to find y.
Oh, so you plug in 0.5 for the x.
That's right. Of the ball, 0.5 seconds. So that represents the x value because that's the time. Okay? So anytime they give you a value, you're going to have to plug it in where it goes. So because this is time, which is x is time, I'm going to have to plug in 0.5 where x is. Okay? So y equals negative 4.9.5 squared plus 9.8 times 0.5 plus 14.7. I want everyone to enter this in the calculator. Make sure you're using calculator properly. Don't forget the negative in the front of 4.9.
This is 18.37.
Let's see. Yeah, 18.375. And now what's my unit? Meters. And then it's a word problem, so what do I have to do? Therefore, the height of the ball after 0.5 seconds. 0.5 seconds after it was hit. Is 18.375 meters. What is the height of the ball when it was hit?
About 14.7.
And why is it 14.7?
That's the initial height of the.
That's the initial height of the ball, right? And remember that initial can be found from the standard form, right? So initial means at the start. So the initial height of the ball is 14.7 meter. These are the easiest questions you can get, and then a lot of times students can't even find the answer because they think it's going to have to be complicated. It's not always complicated, right? The information is in front of your eyes sometimes.
Oh, would the second one be a word question, or would it need a therefore answer?
That's the therefore answer. There's no word, like this is a therefore statement or an answer. How long does it take for the ball to reach the ground? So what am I looking for here? Oops.
The zeros
Mm-hmm.
or a zero?
Maybe more than one, maybe two, maybe I don't know. Where did that go? Okay, how long does it take for the ball to reach the ground? So you're right, it is going to be A0 because we know that it's starting high up. What's the equation again? Y equals what? 4 point negative.
4.9 x squared plus 9.8x plus 14.7.
So I'm trying to find when the ball hits the ground. So I'm trying to find the zeros as you guys said. Can I find it from this form? What do I have to do? Factor. How do I factor?
It's all under product.
Greatest common factor.
Greatest common factor first, right? Because you have an A value other than 1. So I can't do sum and product yet. Greatest common first. So what would be my greatest common factor? Yep.
So anytime there's like on your there's an a value there greater than 1, like if there's something in front of the x, you have to factor.
You guys haven't learned how to factor if the A value is not 1. Right? So the bet, as I said, 99% of the time, for you to be able to factor sum and product, you need to have the A value to be 1. That value in front of the x squared to be 1. And the only way to do that is to factor out that A value. Okay? So I can't do sum and product right now. You have not learned how to do it. Okay? So that's why you have to do greatest common factor first. And your greatest common factor is going to be the A value.
I know I was stuck on one question this morning for like 2 hours.
Then try the A value. Factor it out. Okay, I'm going to factor out negative 4.9. So what happens when I divide each one by negative 4.9? You're going to find that when you divide by the A value, you're going to get whole numbers.
It's going to be 2, yeah.
So x squared, and that's going to be negative 2x. And that's going to be negative 3. Can you guys confirm that, please?
Yes.
Okay, now you see that this looks nice and neat, right? I'm looking for three terms, so that means sum and product.
So multiplies to negative 3
Yeah,
and adds to negative 2.
yeah. Both negative, so the large number has to be negative. What is it? Negative 3 and 1. Okay. X minus 3, x plus 1. So what are my zeros?
-3.
So x equals 3 and x equals 1 or negative 1. So where does the ball hit the ground? 3 seconds, right? The ball, because that negative 1 second does not make sense. But I'm gonna keep it right now because I'm gonna need it for the maximum height, okay? So basically this is what happened to the graph, okay? The ball was here when I hit it, it went up, reached a maximum, then it hit the ground after 3 seconds, and then this is here is just the negative 1. I won't count it because this is where I hit it, okay? So that's why this is dashed, because technically it's not part of your graph of the scenario. It is part of your graph, but it's not part of this scenario, okay? So therefore, the ball hit the ground after
After 3 seconds?
3 seconds, yeah. Or in 3 seconds. How do you find the maximum height? What point am I looking at? The vertex. How would I find my vertex? Okay, so you have your 2 zeros. You're going to have to add the zeros and divide by 2 to find where your axis of symmetry is, right? So first I'm going to have to find my axis of symmetry, which is by adding both zeros and dividing by 2. 3 plus minus 1, that's 2. 2 over 2, that's 1. So that means my axis of symmetry is right here. And then, now I found my axis of symmetry. How do I find the optimal value?
Put 1 into the
Into x. Put 1 into x. You can put it here, you can put it here, it doesn't matter. Okay, you're going to get the same answer. So if I put 1, I like the factored form the most because it's simpler to do. And I think it's 19.6 meter. So what's the maximum height of the ball?
19.6 meters.
So is that the optimal value?
That's the optimal. That's why it's called the max. Guys, we just used everything we learned in one question. Everything we learned in one question. Okay? Hopefully that sums it up for you.